So hi everyone, how you guys doing? First of all, let me welcome you guys to the Unacademy JEE English channel of YouTube and here everything. This is a brand new channel by Unacademy, which is India's largest online learning platform for IIT JEE. And on this channel, every concept of physics, chemistry, and maths are being taught to you completely in English. So this is a series that I started hosting at the request of a few students who wanted the discussion of some Olympiad level problems. Okay, so in this class, we discuss problems from the famous book Pathfinder, the Pathfinder book of physics, which is meant for Olympiads and advanced. So today we'll be talking about problems from work, power, and energy. We already had one class where we discussed some problems from work, power, and energy, and this is lecture number two or discussion number two of work, power, and energy. Okay, so before we get started with today's discussion, let me introduce myself for those of you who don't know me yet. So my name is Rohit Dixit and I studied mechanical engineering from IIT Delhi. And for almost past 8 years now, I've been teaching physics for the JEE exam. And all this teaching so far had been in the offline setups. So offline, I had been associated with some of the topmost institutes that you know for JEE preparation. And I myself, as a student, had secured an All India rank of 447 and an All India rank of 192 in the two stages of the IIT JEE exam that I took. I also had qualified the NTSC Stage 2 examination and I was also in the top 1% in the NSEP as a student. So NSEP, which you know is the National Standard Examination of Physics, or better known as the first stage of Physics Olympiad. So I have been there. I have cracked the Olympiad exam also myself. So and I have been coaching students for a long time for all sorts of competitive exams where physics might be required. So IIT JEE Mains, JEE Advanced, Olympiads, KVPY. So I hope I can help you here with your preparation for Olympiad and advanced level problems in this session. Okay. So how can you also make sure that your studies go uninterrupted in this lockdown period also? So you can get yourself the Unacademy subscription. This subscription will give you benefits like live classes where you will give to interact with your educators on a regular basis. Then you have live polls and leaderboards in these classrooms which keep them highly interactive and fun. You also have test series and analysis sessions which keep you on your toes and aware of the competition, or you're standing in the competition as you're preparing. And of course, you have live doubt clearing sessions. So at after every three teaching sessions in the Unacademy Plus courses, every fourth session is supposed to be a live doubt clearing session. Okay, meets. All right, good to know that. So you seem to be the only active one here, though. I don't know what is happening to others. Now, on top of all these benefits, Unacademy is also providing you the chance to study from the top educators from all across India from the comfort and safety of your home. So make sure that you are getting this subscription and making the best of it. So these are the online courses which are running on the Plus now currently for 2022 aspirants. So three courses, including an advanced course on mechanics that I am taking. And then you have four courses for 2021 aspirants. So class 12 topics, including one course on advanced, which is advanced course on electromagnetism that I'm taking. All right, so how do you enroll in these courses and how do you make sure that your preparation goes uninterrupted and better than the rest? You need to install the Unacademy app first. Once you have done that, select your, you go to the plus section of your app, select your goal as IIT and click on that get subscription button. Now, when you do that, you'll be redirected to the payment page where you'll have a column which will say, do you have a code? So that is where you can use my code RD Live. So if you use this code, you will get a 10% off on all your subscription fees. And when you click on proceed to pay, you will also realize that no cost EMI is available for all subscriptions of 6 months and above. So trust me, Unacademy is providing you quality education at very competitive prices. So any offline coaching would charge you anywhere between 4 times to 8 times this fees. So I know that because I have been a part of offline coaching setups for almost 8 years. So Unacademy is providing you same quality education from the same top educators at a very affordable price already. This will be made even more affordable if you use this code RD Live. So what are you waiting for? Go get yourselves these subscriptions and get ahead of your competition. All right. So again, let me also remind you that Unacademy Combat is going on. This is the most competitive gamified version of the IIT JEE. It's a quiz kind of a contest, so you can compete live in this and win rewards and prizes if you do well. So the next event of Unacademy Combat is going to be happening live on 22nd of November. Don't forget to enroll in that using this code RD Live. So and all the best from my side. Do well and win yourself some cool and awesome prizes. For those of you following us on the JEE English channel of YouTube, can connect with us on the Telegram app using this link. Okay, so make sure that you are joining us so that you're getting all the notifications of all the lectures and special sessions happening on the JEE English channel of YouTube. On YouTube. Okay, so without any delay, let's get started with today's session then. So today is the part 2 of the session on work power and energy. Last time we discussed some problems. We did not manage to discuss too many because I think one particular problem took a lot of time. So today we'll carry forward a discussion from there. So this is the first question that I think this question I introduced in the last class only. And why don't you guys give it a try? This is a very, very interesting problem. It says two identical ropes A and B of uniform mass per unit length are suspended from a ceiling and are made to pass through a metallic tubular structure C as shown in the figure. So you can see in the figure that there is one rope here which is passing through this tube and going all the way down. And then you have an identical tube, identical thread here, which is going like this, passing through this tube and going all the way down. This is the structure that you have. Okay, and these two ropes are uniform and they have the same mass per unit length. They are absolutely identical. Okay, so let's see what the question says. The structure is made of welding two ideal bent tubes. So you will realize when you're talking about this structure, so these are two bent tubes which have been welded together. So this is how this structure was made. And you are told that this structure is almost inertialess. So what does that mean? That means it is massless. So initially the structure is held at rest and released. Now what will happen in the subsequent motion? A, it will not move at all. B, it will move downwards with a speed decreasing at a rate of 0.5 g. That is with an retardation of 0.5 g. C says it will move downward with a speed increasing at the rate of 0.5 g. That is with an acceleration of 0.5 g. And D says that the rope will heat up. Why don't you give this a quick try and let's see if you can figure this one out. Okay. So Meet, why don't you give this a try and you can maybe let your other friends also know to join this lecture. So let's try and solve some really challenging problems. I know I always used to enjoy this. Solving challenging problems is always fun. Okay, so let's challenge ourselves. Let's see if we can manage this. Okay, so I am waiting for people. Let's see if you can figure this one out. Very, very tricky, interesting problem. Okay. So those of you who are trying can write trying in the chat, by the way. Okay, so that I know you guys are trying and I know who to wait for. Okay. Okay, so you can let me know in the chat in case you're trying. So I don't know how long should I be waiting or who is trying, if anybody is trying at all, that is. Hello AP, good to see you here. How are you? So are you trying this problem? Meet says if two particles are moving in concentric circles of radius r and 2r at time t equals 0. Uh, okay. Both were in the same place. One is moving with 2 omega ऊपर वाला and another 3 omega नीचे वाला. If they move in opposite direction, at what place will they meet and when will they meet? Okay. First of all, I'm not sure what you are trying to say here. Two particles are moving in concentric circles of radii r and 2r. So why will they move, or do you want to know that when will they come along the same straight line? If they are moving in different radii, why will they meet? All right, hi guys. So I think you have meet. You have something missing in your question. Okay. Yeah. So let me add a page and try and explain what you're saying. So what you told me was that, see, two particles are moving in radii of r and 2r. So let's imagine one particle is moving like this. And, this is moving in a radius r, and another particle is moving in a radius of 2r, right? It's moving like this. So do you want to know when they will be in the same straight line again? Okay. Yes, so that's what I figured, no? Yes, you got the question wrong. Okay, hello guys. Okay, so let me just answer Meet's query and then I will quickly solve this problem. So yes, two particles at t equals 0, they were both at the same place. So essentially, let's assume that they were both uh, here. One was here and another was here. So they were both along a straight line. That is what I'm assuming when you say both were here. And one is moving with 2 omega upar wala and another is moving with 3 omega niche wala. Okay, so I'm assuming bahar wala or andar wala. Okay, so this is moving with 2 omega and this one is moving with 3 omega. Right? When will they meet? If they will. यही पूछ रहे हो. I hope I got your question right. So all you need to do is you realize if they meet at some point, then what will happen? So let's say that here they are again at the same straight line. Okay, here, and the other particle gets here. So they are again at the same straight line. So let's imagine that this is what you mean by your question. That when will they be again in a straight line or next to each other, right? So assuming that they are meeting at some place, so you want to ask they move in the when they will meet and at what place they will meet, right? Okay. Yes, Abhinav. Sadly enough, not too many people are interested in good questions of Olympiad, I guess. So how about you? Can you try this, Aditya Abhinav? Why don't you try this problem? And let's see. Okay. So as I was saying, so if this is where they meet, so if I assume that this angle is some theta and this angle obviously is pi minus theta. So can you say in time t, if that happens, then this guy would have moved with 3 omega. And can I say that theta would have been 3 omega times t? So that is my equation number one. And for the second one, I can say pi minus theta would have been 2 omega times t. Okay, that is the second equation. So I can divide these equations and I will get that theta over pi minus theta would be equal to 3 over 2. So I can say 2 theta equals 3 pi minus 3 theta. So theta I will get as 3 by 5 pi. So that is the location where they will meet. And the time obviously is, you can substitute the value in any of one equation. So from one, what you will get is 3 by 5 pi would be equal to 3 omega times t. So t will be pi over 5 omega. So that will be your answer for time, and that is the location where they will meet, okay, which is theta counterclockwise or clockwise rather, clockwise from their initial position. Okay, did you follow this, Meet? Let me know if you followed this solution. That is how you would have gone about it. Okay. Hello, Sahitya. Okay, Aditya, Abhinav, are you trying to give the answer or something else? So just let me know what will be the answer of the question that I gave. So first try and give the answer, and then try and make any other comment. Okay. So I don't know. I hope Meet you followed this. So this was the question that I had presented you guys. So uh, tell me if any one of you can solve this. Okay, try. What will be the answer of this? Okay. So Aditya, Abhinav, I don't know. I don't know what your aim is here. I hope you're trying to solve some Olympiad level problems. Let's see if you can figure this one out. So why don't you focus on trying to solve this problem? Hmm? Okay, let's see. Let's see if you can figure this one out. Okay, sure, no problem. Neil. So anybody able to figure this one out? Let me know. No problem, Neil. So if nobody is able to figure this one out, tell me. I will show you how you would have solved this. Okay. Does anyone have any idea how to approach this? How about Aditya, Abhinav? Do you even have a clue of how to solve this problem? Try it. Give it a try. Okay. This is what the question is. Why don't you give it a shot? So those of you who are attending this, let me know if you're trying. If anybody is trying, you can write trying in the chat. Otherwise, I will probably go ahead and just solve this. All right, no problem, no problem. Let's see if he's good enough to solve something other than disturbing. Okay. And I really don't care. He's just wasting his time if that's his motive. Okay. So how about anybody else trying this? All right. So I don't think anybody is trying this. So how you would have solved this? Let's take a quick look. Now let's read the question carefully. So you have been told that there is no friction. There is no friction between the ropes and the tubes, and the structure is almost inertialess. Okay, so there is no friction anywhere. So what do you think will happen to this structure? Will this move down, or will this just hold its position? What do you think is the difference? So see, what is happening is that if you notice, if this came down like this, then is there any difference? See, the lengths here are same, so the potential energy here is same. The lengths here and here are again same. The potential energy here is same. However, this portion has come down. This portion has come down. So this has lost some potential energy. So you realize this will try to come down. Okay. All right. Oh, that's great. Congratulations, AA. Okay. So you realize whenever any system is left on its own, it always tries to acquire a lowest potential energy configuration. So if this rod comes down, then this portion which is contained passing through the tube is lowering its potential energy. So that is why this rod will definitely go down. Okay, so that's the first thing that you need to understand, that this will come down, because if the bar lowers down, if this rod lowers down, then the potential energy of the system is getting reduced. Okay. Now, let's try and see by how much can we calculate the acceleration with which it comes down. So let's imagine at any time if this bar is moving down with some velocity v, okay, then you will realize that inside the rod, this rope will also have to move with v. Do you agree? If this bar is coming down with v, so inside the rope that is contained in this region, this rope would be moving in this direction with v, and here the rope would be moving in that direction with v. Do you guys agree? Okay, so D. Okay, everybody is saying D. No, the correct answer is C and D, turns out. Okay, I will just show you how you are getting that. So I hope you realize that when this rod comes down by V, so what is happening is, let's assume in some time, in 1 second, what is happening is, imagine in a small time it would have come down to a length v dt. It would have come down by a distance v dt. Okay, let's assume in time dt it comes down by a distance of v dt. So this v dt length would have gone from here to here. It would have slipped in the tube. Agreed? So we can conclude if at any instant, the tube travels down with speed v, then the rope slips with respect to the tube with the same speed v. Correct? I hope you guys followed this. So if that is the case, if I see in the reference frame of the tube, what will be happening? The string from here would be going up by v and slipping through the tube and eventually going up and adding up here. Agreed? I hope you can visualize that. To visualize that, you can go into the reference frame of the tube. If you're in the reference frame of the tube, so the entire wall, you realize, will go up by v. The wall will go up by v, so upwards these ropes will move by v. This rope would start sliding with v with respect to the tube. Okay, so I hope everybody can realize that. So I know the speed of the rope segment with respect to this v. Now this tube itself is going down with v. So the segment that is contained inside the tube has two velocities. With respect to the tube, it has v velocity like this, and because the tube itself is moving downward with v, so it has another velocity v. Okay. So can I say with respect to ground, this rope, the rope in the tube has two velocities, right? Is moving with two velocities, or can I say v root 2 speed? Let me know if you followed this. Because with respect to in the reference frame of the rod, if I see the wall would be going up by v, I hope you can visualize that. It is easier to visualize in the reference frame of the tube. Okay, what is the reference frame of the tube? Imagine the entire wall going up by v, so all these strings are being pulled by v, so the string in the rope would be slipping with a v speed only with respect to this. And since the tube itself is going in downward direction with a speed v, so in the ground frame, the portion of the rope that is contained inside the tube will be moving with a speed of root 2v. Agreed? Now all I need to do is that if this thing I can also say if this thing goes down by a small amount of height dh, or let's say dy. Hello Srinjoy Das, so good to see you. Okay, so I don't know if you've tried this problem, so I am trying to solve this problem here. Yes, 24 minutes late, absolutely. Okay, so now all I need to do is I need to remember the facts that were told to me. What was I told? I was told that there is no friction between the ropes and the tubes, and the structure is almost inertialess. So this is massless. So you realize the speed that this tube is gaining, or this rope, the speed that this portion of the rope is gaining, where that is coming from? That is coming from the potential energy that it is losing as it is going down. I hope you realize that if it goes down, so whatever potential energy it is losing, that will be gained as kinetic energy. That is why the speed will increase. So two things I can say: one, it will go down; second, I can say that the speed will increase. So definitely this is not true, this is not true. So that leaves me with options C and D. So let's see if C can be correct. Now can I say that since the kinetic energy plus potential energy of the system will remain constant, okay, will remain constant. Why? Because there are no non-conservative forces acting on my system. Okay, if I take all the ropes and the tube as my system, there is no non-conservative forces acting. There is only force of gravity that is making this rod slide. So can I say that dk would be equal to minus du? If I differentiate this expression, then this is what I'm getting. So let's represent the potential energy with u. So all I need to do is, let's imagine it slipped down by a small distance dy. So if it slips down by a small distance dy, which is v dt, then what is the change in its kinetic energy? Okay, so I'll have to add one page. Let's add one page here. So I can say since at this instant it was moving with a velocity of v. Why is it not moving? Page? Here it is. So can I say right now what was this k kinetic energy? That kinetic energy was half. Now you will also realize that the mass in the tube, mass of the rope in the tube is constant. Always the same mass of the rope will be in the tube. Okay, okay, so my video is lagging. No, I don't think so, not anymore. Okay, I don't know why that is happening. If that is so, it seems to be working fine. I am trying to watch my own stream. Seems to be running okay. Yes, yes, there does seem some lag. I don't know why. That is strange. I don't know. My net settings seem fine. Everything, everything seems to be. The speed is fine. I just checked the speed also. I don't know if there is a lag. Why it shouldn't be. Let's see. Maybe in some time it will get all right. Let's give it a few minutes. Okay. Previously it was happening. Now it's okay. Okay. All right. All right. So as I was saying, if at this instant it had a speed of v, then can I say that the kinetic energy would be half mv square? Kinetic energy would be half mv square, where m is the total mass contained in both the tubes. Right. Now both the parts would be moving with a net speed of root 2v. Okay. So instead of v, you will write, but you should have written root 2v. Great. So that will be the kinetic energy of both the parts of my ropes. So kinetic energy at any time I will realize is mv square. So that gives d kinetic. dk would be 2mv times dv. Okay, I hope you can see that. Now I will also realize if the potential energy, if the height at any time was y, so mg y, so dq would have been minus mg dy. Why am I including a minus sign? Because this is coming down. So since this is coming down, its potential energy would be getting reduced. Okay. So therefore, I can say therefore 2mv dv should be equal to mg dy. Agreed? This is what I can write. Now m and m would get cancelled, and if I divide both the sides with dt, so I can say 2v dv over dt would be equal to g times dy over dt. Now dy over dt is nothing but v. dy over dt is nothing but v. Okay, I hope you can see that. So this and this gets cancelled, and what you have is dv over dt, which is nothing but the acceleration is g over 2. That is going to be your answer. Okay. I hope you guys followed this. Let me know if that makes sense. So we could find out the acceleration using energy conservation. I know that the kinetic energy of the rope is being gained at the expense of the potential energy that it's losing. Okay. So here I have option C as correct. So now you would wonder, why will the rope heat up, or will the rope heat up at all? So turns out what will happen when this comes all the way down. When this comes all the way down, you realize the rope would have had some kinetic energy. Okay, and when it comes all the way down, you would have had two ropes hanging like this. So that kinetic energy, the final kinetic energy would be zero. So the kinetic energy that it is gaining during its downward motion, that finally would be uh, dissipated, and that is why this rope will heat up. This rope will heat up at the towards the end of the journey. Okay, when there is no more rope left to gain that kinetic energy, then all that kinetic energy will start getting dissipated in form of heat, and that is when the rope will heat up. So you can let me know if you followed the logic and if you followed the solution. If there was any part of the solution that you did not follow, then you can tell me. Okay, so Meet is saying, sir, you understand my question very well, but I think it is given when they will come in the same line. Oh, okay. 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 So same line. So okay, that can move to mean two things. That can mean two things. Whether are you talking about the exact same line where they started from? Okay. So are you talking about this straight line? So when they will be back at this straight line together, or when they will be at any straight line? So what is it that you're trying to ask? So there are two possible meanings. So one could be when they will be back at the exact same line from where they started. Okay. So both cases are not the same. And second is, so I don't know, there are multiple meanings that are possible in your question. Okay. So you will have to first clarify the meaning of your question. Okay, I don't know what you're trying to ask here. Okay, what you're saying is slightly incomplete and confusing. Okay, so yeah. So I don't know what exactly the question is asking. So it would be better if you could present your question in a more clear manner. By the way, I hope everybody followed this solution. Is this solution clear to everyone? So let me know about this problem. You guys follow this? That we use the fact that the reason, first of all, the rod will come down. Why? Because if it comes down, then the system's potential energy will be lower. So we know that any system when left on its own will always come down and try to attain lower and lower energy. Okay. So if the rod comes down, definitely the potential energy of the system is lowering. Okay. So that is why it will come down. And as it comes down, it will be losing potential energy, which will be gained as the kinetic energy of the ropes. So that is why I know it will accelerate, the speed will increase. And from energy conservation, I can say that the increase in kinetic energy at any instant in some dt time would be equal to the decrease in the potential energy in that same time dt. So using that, I first of all, I figured that if the rod is moving with a velocity v, then the rope would be moving with a velocity of root 2v. I hope that was clear. In the reference frame of the tube, we could see that the rope would be slipping like this with a speed v, and this tube itself is going down with the speed v. So in the ground frame, the rope in fact is moving with the speed of root 2v. Okay. So since we know that, so the kinetic energy of the rope, that is the only part which carries mass. The tube has no mass. So tube will not gain any kinetic energy. So all the kinetic energy would be gained by the rope. And this will be the kinetic energy of the rope at any instant where the tube is moving with a speed v. So at any instant when the tube is moving with speed v, the kinetic energy of the rope can be written as this. So if I differentiate this in dt time, this is the loss, this is the gain in kinetic energy. And if it comes down by a distance dy, this is the loss in potential energy. Now, loss in potential energy should be equal to the gain in kinetic energy. That gives me this relation, and that tells me that dv by dt, which is in fact the acceleration of the tube, is g by 2. Okay. And as I said, at the end of the motion, in the end of the motion where there will be no rope left to gain any kinetic energy, this energy would get dissipated, and that is why your rope will heat up. Okay, sir, please ये सीरीज कंटिन्यू रखिए. ओके दिव्यांश. सो यार अगर अगर आप लोग इंटरेस्टेड हो, इफ यू गाइस आर वाचिंग, अगर आप रेगुलरली पार्टिसिपेट कर रहे हो तो मैं कंटिन्यू रखूंगा. मुझे कोई इशू नहीं है. आई इन फैक्ट एंजॉय डिस्कसिंग गुड क्वेश्चंस. ठीक है. आई गेट बोर्ड इफ यू नो आई एम डिस्कसिंग टू मेनी सिंपल क्वेश्चंस. वो तो यार इतने साल से पढ़ा रहे हैं, मजा नहीं आता उस पर भी. So I will enjoy such a series more but then if there is active participation from your side, okay, Divyansh. So make sure you guys keep actively participating, and I will continue this series. Okay. So yes, Meet says no any straight line. So any straight line, if they are moving in the opposite direction, then this is the answer. Okay, let's call this T1. Okay, this will be the answer if they were moving in any direction, in the opposite direction. This would have been T1. If they were moving in the same direction, then what would you have done? Then you would have thought that if they meet somewhere here, so one guy would have completed at least one circle more. Or you could have just said that find the relative omega. If you find the relative omega, so that is another way of solving this, by finding relative omega. That is why you were asking about relative omega, right, me? So that is another way of solving this. So I could have solved it like this, the way I did. There was another way of solving this where I could have used the relative omega, and I could have said that, okay, when these two particles are moving, okay, so one is moving with 3 omega and other is moving with 2 omega, right? So if I go to a rotating reference frame, other guy moving with 2 omega like this. So imagine if I am in a rotating reference frame which is rotating with 2 omega. Okay. So in that reference frame, this guy will appear stationary to me, and this guy will appear to be moving with omega. Okay. So when will this come back again? Whenever it completes an angle of 2 pi. So time t2 would be 2 pi over omega. Okay. In the first case, you would have realized that since this was moving in this direction with omega, so if I'm in a reference frame which is moving, rotating with 2 omega like this, then this particle would have again appeared stationary, but the other particle would have appeared to be moving with 5 omega. So if this is stationary, this will meet the second particle at time t1, which will be 2 pi over 5 omega. Okay. So those would have been your answers. 2 pi over 5 omega and 2 pi over omega. Okay, so here I did not get 2 pi. Okay, why not? I should have gotten 2 pi. Why am I not getting 2 pi? Let's see omega. Okay, that is weird. Oh, yeah. Here is the mistake. Here is the mistake. I wrote this as pi minus theta. This will be 2 pi minus theta. This will be 2 pi minus theta. So here you need to write 2 pi minus theta. And here again you will have 6 pi. So you will have 6 pi by 5. Okay, and obviously that would have given you your answer as omega by 2 omega by 2 pi by 5 omega. Okay. Sir, in JEE type of question is coming. Yes, in advance they have asked some questions. Okay. In advance, JEE advance has asked some questions where you need to use relative angular velocity. But relative angular velocity is very easy to calculate. If both the bodies are moving in the same sense, then the relative velocity will be negative one minus the other. If they are moving in the opposite sense, then it would be one plus the other. Okay. Okay, and now I hope you are satisfied. Okay, me. This was the answer. I missed out that 2 pi. I wrote by mistake pi minus theta, which is wrong. Okay, so you could have solved this using the approach of relative omegas, and there you would have easily got the answers. All right, so once this discussion is done, I hope everybody followed this discussion. अगर किसी को इसमें कोई issue है तो बता दो. So if you followed this entire question solution, then let me know, should I move forward? भाई ये सबको समझ में आ गया? Everybody followed this. If all of you followed this one, then let me know. I will move on to the next question. Because I wanted to discuss a lot of questions today, and we are already 45 minutes into the session, and we are only at question number 1. Okay. So can you let me know fast? All right, I'm waiting. So if everybody followed this, should we move on to the next one? If there is any part of the solution that you did not follow, you can let me know. Okay. I think it's due to all. Let's move and discuss another one now. So here you've been told a small disc is placed on a frictionless horizontal table and is attached to at one end to a light inextensible cord. Okay. The other end is attached to a vertical cylinder fixed on a floor. Okay. You have a vertical cylinder about which one cord is connected, and at this end you have a disc. Now you've been told that the disc is now projected at a certain velocity perpendicular to the cord. So you have a disc connected to this cord. You initially gave it a velocity like this. What will happen is that it will wrap around the cylinder. That is what it will do. It will start wrapping around the cylinder. Now what you have to find is that how will the tensile force or the tension in the cord and the speed of the disc change during the following motion. in the motion that follows. So option A says both will increase. Option B says both will remain constant. Option C says tensile force will increase while the speed will decrease. And option D says the tensile force will increase while the speed will remain constant. Okay. So you can try and answer this. Now, a very interesting problem, very similar to this, actually was given in Irodov. Okay. All right, Meet. There, what had been asked was there. I think they have asked you to find the time in which the disc will be able to get that point mass will hit the cylinder or will wrap out completely around it. So I think if I remember that correctly, the question was that this radius was given and the length of the cord was given L naught, and you were told that this is mass m, this is given a velocity v like this, and the cylinder is fixed, of course. So you realize when it moves, this is what will happen. This will keep wrapping up. So because of this, the length of this cord will keep shortening. In some time, this will end up hitting the cylinder. So in Aerodov, they had asked at what time does it hit the cylinder. So that is another interesting problem. So once you figure this out, maybe we can discuss that also. Okay. So can you figure this one out? So anyone trying this? Again, guys, if you want this series, then try and be more active, participate more actively. Okay. Otherwise, there is no point. See, I don't know how many times do I tell you. One, you guys won't learn if you're actively participating in a discussion. Okay, these are very tough problems. So I can keep saying things, but if you're not here to, or if you're not sharing your views of whether you're following whatever I'm saying or not, or whether you're raising your doubts or not, so I don't think it works very well for you. Okay, I can discuss all the problems of this book also, but trust me, it will help you more if you could see these sessions, attend these sessions live, and be a part of the discussion. Okay, so try this quickly. And okay, so I hear a doorbell, and since I live alone, so just give me 2 minutes to check that out, and you guys can try this till then. Okay, so do we have any answer? Okay, not yet. Great. All right. So let's see. Okay. So first of all, what you need to realize is that let's talk about the disk. Let's talk about the small disk. So what are the forces acting on the disk during its motion? This is the top view. This is your cylinder, and this is the cord. And imagine that this is the disk. And initially, it was given a velocity v like this. Now you realize the only force acting on this is the tension, right? This entire setup is on a frictionless horizontal floor. Okay, so the only force acting on my disk is the force of tension, correct? And when this reaches here, let's imagine that after some time, this is the situation. Okay, so you realize that still the force acting on it is again the tension force. That may be different. So let's say T dash, and let's assume the velocity is also V dash. Now, do you realize that the only force acting on this particle will always be perpendicular? No, A is not correct. A is not correct. So the correct answer, in fact, is D. Okay, AP. Good try, but this is a tricky problem. So you realize that the tension is acting like this. Now, tension is perpendicular to the velocity, so it cannot do any work. It can only rotate it. So as it rotates, so consider in some time dt, what will happen? In some time dt, it would have just rotated the velocity vector. Yeah, I hope you realize that the velocity vector is only rotated and the tension is again perpendicular only to the velocity vector. So you realize the tensile force, whatever it might be, it will always be perpendicular to your velocity vector. That is why this force cannot do any work. And there is no other force acting on my disk. Okay. So what I can write is, since the only force acting on the disk is T, which is always perpendicular to V. So you realize that there is no power that is getting delivered to the disk. So the velocity or the speed, rather the velocity is changing because this force will change the direction of the velocity vector. Therefore, the speed of the disk remains constant. I hope that is clear. That is very, very simple, very, very easy to see. The only force acting on the disk cannot do any work because it is always perpendicular to the displacement vector. Okay, so if it cannot do any work, it cannot change the speed. Okay, I hope you remember that from your work energy theorem. So I can say that speed will remain constant. Okay. Now, how about the tension? Does the tension remain constant? No. So here, if this length was L naught, and if this length, you talk about this length would be lesser than L naught, correct? And this point would be fixed. So at this instant, this is moving in a radius x, and initially it was moving in a radius of L naught. So you will see that at t equals 0, this disk was performing circular motion with this center in a radius L naught, and at some time later, it will be performing circular motion around this point in a radius of x. So you will realize that who is providing the centripetal acceleration for this? That is being provided by tension. So the circular motion the disk is performing about different points, because the point of or the center of the rotation is changing constantly. So the radius of the rotation is also changing constantly, and I can say that at any instant, your t would be equal to v square over x. Now, since x is decreasing, so you realize t will increase. So yes, very well said, Tanya. So tensile force will in fact increase while the speed remains constant. Okay. Now, can you figure out what is the time in which it will hit? You figure that out. So let me give you a hint how you could have done that, how you could have found the time in which it would have hit. So that is another very tricky problem. But let me show you. Since we are discussing this, so why not show you that also? Let's see. So let's make ourselves the situation that we had. So here is your cylinder of a radius r, and here was your string of length L naught. Okay. Now consider at any instant when this is here. Let's say that this is here. Okay, and this is x. So in a small time dt, this would have come here. So this would have rotated, and you realize that this is the line. This line would have rotated by some angle d theta. If this was d theta, this is the angle by which your string would have rotated, then I hope you realize that this radius vector also, radius vector is always perpendicular to uh, the point at which the string is coming out, right? So here you realize that the radius is like this. Here the radius vector would be like this. Let's use another color for that. And here the radius vector is like this. So you realize this radius vector is also turned by an angle d theta. Can I say that this angle is also d theta? So how much length gets wrapped up in dt time? So or I can also assume that in dt time this x is constant. So this distance moved ds would be x d theta. I hope you can realize that. Okay. When the string length or the length of the free string, let's call it, when the length of the free string equals x, in dt time, I will notice in dt time, the length that gets wrapped, the length getting wrapped around the cylinder, how much is that? That will be x r d theta at times. Agreed. Where d theta is the angle by which it turned. Okay. Now you can also realize that how do I calculate a d theta? D theta would have been ds over x, okay, arc over length. And I know d theta over dt would be equal to s over dt times x. So that is v. V is constant, v over x. Okay. So the length wrapped, so dl, let's call that dl. dl is equal to dl over dt. The rate at which the length is getting wrapped is capital R times v over l. That is the length that has gotten, that is the total length right now, and dl length would be reduced in some time, right? Or let's use dx only, where dx is the length that got wrapped. Okay, I hope you realize that this will be the equation. All you need to do is integrate this. You will realize x dx would be equal to r v dt, and you will integrate this from x, which is the length that got wrapped, or sorry, l x was the length, total length, that will go from l naught to 0. Okay, hope you can see that. And the length wrapped would be, okay, the length wrapped would be minus dx over dt, by the way. Why minus? Whatever length dx is getting reduced, that is the length getting uh, wrapped up. Okay, so here you will have a minus sign. So all you need to do is integrate this and integrate this from t equals 0 to t equals t. What you would have realized is that L naught square by 2 would be equal to R V T, and that would have given you the time in which the string gets wrapped up is L naught square over 2 R V. That would have been your answer. You can check out this problem in Erodo. Very, very interesting problem. And this is how you could have found the time in which the entire string gets wrapped up. Okay. I hope you followed this. And I just decided to show you because I find this problem particularly interesting. Okay. All right, moving forward. This is another very, very interesting problem that I have for you. So why don't you try this? If you have any query regarding the solution that I showed you or the discussion that we had about this problem, then you can let me know in the chat. Okay, and if there are no worries that if everything is clear, then let's move on. Okay, moving forward, another very interesting, very tricky, a slightly tricky problem. So again, all these problems I find are very good problems for your JEE advanced level questions or even Olympiads. So all these questions I find very appropriate for your advanced. Any of these questions can be asked in advance. They're very nice, based on fundamentals, very simple fundamentals. If you have a fundamentals clear, trust me, problem solving is not very hard. But you just have to think about situations. So that is new. So let's try and see this problem. So here you've been told a frictionless rod ABC. So ABC is a frictionless rod. Okay, and a particle P of mass small m are lying on a frictionless horizontal floor. So let's highlight the key parts. So first of all, frictionless rod and a particle P of mass m are lying on a frictionless horizontal floor. Okay, as shown in top view. So this is the top view. Please remember top view of the situation. Now the portion AB of the rod is bent to form a quarter circle. So that is in form of a quarter circle. I hope you can see that. Now the rod is suddenly moved with a constant velocity v towards the right. So towards the right, which means that you suddenly started moving. So this, both these things are kept on a horizontal frictionless surface, and you are seeing it from the top. Okay, please remember this. Now you are starting to slide this with a constant velocity v. You started sliding this end towards right, the constant velocity v. Okay. Now let's see what it says with constant velocity v towards the right along the portion BC. So along the length BC, it is being slid towards right with a constant velocity v. Now what will be the work done by the rod on the particle till it leaves the rod? The work done by rod on the particle till it leaves the rod. See, what will happen is when you are sliding this, so you will see that this particle will shift with respect to this rod. It will come at the curved portion and eventually it would have left it. Okay. So what is the work done by the rod on the particle till the time it leaves contact? So why don't you give this a try? Again, a very interesting problem. Okay, so try this. So first of all, do you understand that work will be done? Work will be done on this particle P. Who will do the work? Think about it. It will be the normal reaction. So if the entire rod was straight, then there would have been no work done, right? The rod would have simply slipped from below. Okay. So this is a frictionless rod. However, the curved portion will cause some work to be done. When this is slipping, when this comes, then this curved portion will essentially hit this and make it move forward. Okay, Norman. I didn't know that. Maybe somebody took that name, or is it the writers only who have? Okay, so Rajesh is C. I don't remember actually. Think I think if I remember it correctly, the answer was not C. Okay. If I remember correctly, the answer is not C. Anyways, we are not too bothered about the coaching center. We are only bothered about the interesting problems that this book presents. So the idea is to present you with some challenging problems. Okay, so if you are aiming for top ranks, then you should try these challenging problems so that they will open your mind. Okay, they will help you. Okay, so why does this keep happening? Okay. Oh, I think I've put my iPad with to be in sync with Mac, so that is why this must be happening. Okay, so Amod Kumar says A. So unfortunately, no. This and this both are wrong. In fact, if I remember the answer correctly, it was this. Okay. So anyone else trying this problem? So these are some really interesting problems of different situations. These all of them can be solved using basic concepts. This will test your knowledge of understanding of basics. and how much you can think of the concept from the with the help of the concept that you already know. Okay, so that is what. Yes, Mahiji. Now easy to figure out. No, after two I've told are wrong. Okay, all right. So that is why I like discussing this problem. This should present you a challenge. It should stimulate your brain. You should try and think about such problems. So if you really understand all your concepts well enough, you should be able to solve all these problems. Trust me, there is nothing new that you're doing in these problems. As I said when I discussed the previous two questions, also I think conceptually there is nothing new that you're using, right? Everything that we use to solve the question is everything that you already know. So it's just that you are when you see more challenging problems, then you are forced to think more. That is the entire idea. The entire idea of this session is to present you some really challenging problems, force you to start thinking beyond what you already do. Okay, stimulate your brain a bit. So, anybody trying this, or should I show you how this is solved? Let me know. Okay. So again, one more thing. If you want to solve problems like this, if you want to catch a top rank in the JEE, stop being so lazy and respond some more in the chat. Yeah, I think only 3-4 people keep responding constantly, where more people are online. I don't know. All right. Anyhow, so let's go ahead and see the solution. How to solve this? Does anyone have any hint? You have any idea how you would have solved this? How you would have approached this? So see, I'll tell you what is happening. First, let's think about what is happening. So imagine this was my rod. This was my small particle. So let's keep it there. Now the rod is being slipped. So since there is no friction, this disc feels no force, right? So till the time this reaches the curved portion. Now at the curved portion, the normal reaction starts to act. This normal reaction will act and move it like this. Okay? And then it will have left contact, moving with a constant velocity. So if I can find the velocity that it gains at the time it loses contact, I can find the work done, because the only force that can do work and that can increase the kinetic energy of this P is the work done by the rod. Okay. Now all I need to do is figure out with what velocity the point P has when it leaves contact with the rod. Okay, so let's think about it. Now the easiest way to think about this is look at the situation in the reference frame of the rod itself. Okay. So this is what you get when you have practiced switching reference frames a lot. So I used to do this a lot. If you can smartly switch the reference frame of observation, trust me, problems become super easy. Okay, so make this a habit. In the reference frame of the rod, in the reference frame of the rod, okay, so that's a bent rod, yeah, rod ABC. What you will see what you see. So in the reference frame of the rod will be stationary. Okay. The rod would be stationary, and you will see that this guy will be moving with a constant velocity v. Agreed? Now, as it moves from here to here, will its speed change? Will its speed change? The answer is no. Remember, this is all happening on a frictionless horizontal surface. Please remember that. This is all happening on a frictionless horizontal surface. You are only watching the top view. So don't think, nahi sir, it is gaining potential energy. It is going up. Nahi, nahi. It is not going up. It is all happening on a smooth level. Okay, so on a smooth level, you realize that when it is slipping, there is no friction. So friction cannot do any work. And the normal reaction obviously is always normal to the motion. Okay, I hope you realize that when this particle was somewhere here, particle is somewhere here, then it is moving in a circle, right? So if it is moving in a circle, it has a velocity like this. And what is the direction of normal? The direction of normal is like this. So in this reference frame, the normal cannot do any work. If the normal is not doing work, there is no other force acting on it. So there will be no work done. So what will be the velocity when it leaves contact? When it leaves contact, then it will have a velocity v upwards. Okay. I hope you can see that. In the reference frame of the rod ABC, particle P moves with a constant speed. I hope you guys agree. And why is that? As no force does any work on it. Now, please remember that we are already in an inertial reference frame. So you don't even have to worry about pseudo forces. This is moving with a constant speed. Okay. So as no force does any work on it. So can I say when it leaves the rod, it has a velocity of y upward in with respect to the rod. So if I choose this as my y-axis and this as my x-axis, so can I say that when P leaves the rod, when P leaves the rod, velocity of P with respect to rod is j cap. Correct? What is the velocity of the rod itself? Velocity of rod is constant, right? It is vi cap. So now, can you figure out what is the velocity of P with respect to ground? Very, very simple. Velocity of P with respect to ground would be vector sum of these two. So vi cap plus vj cap. So what is the speed? Okay, so the speed of P would be root 2v. That's it. Once you figure that out, now you know what was the initial kinetic energy. Initial kinetic energy was 0. What is the final kinetic energy? Final kinetic energy, since I can say since k initial was 0 with respect to ground, okay, k final is half m into root 2v whole square, that is mv square. So according to work energy theorem, what is the work done by the rod on this particle P? That will be the change in its kinetic energy. Therefore, according to the work energy theorem, can I conclude that work done on P by rod equal to mv square? Okay, work done change is equal to change in kinetic energy. That's why I have B as my correct option. Okay, so RNL is saying, sir, is Unacademy Plus free? No, Unacademy Plus is not free. Unacademy Plus is not free. You have to pay a subscription fee, which I will tell you towards the end of this class also. If you watch the class from the starting, I tell you about the subscription fees at the beginning also. So Unacademy Plus is not free. On YouTube, we are providing free content. Okay. All right. So let me know if you guys followed this. Any issues with this solution? This is very simple. Once you know how to think, then trust me, things appear very, very simple. So if you don't know how to approach this problem, this can appear like a really complicated problem. You have no idea, okay, what is happening here? Why will this, or how do I calculate the work done by the rod? Okay, so if you get some practice, if you start to learn how to think. So as I think I told somebody, I think someone initially had asked me that, sir, how do we think like that? So the only answer is through practice. If you practice some such questions, if you start thinking on those lines, then you will develop that thought process. Okay. And once you develop that thought process, trust me, you will solve all tough looking problems like this. Okay, so that is how easy it gets. So how do you think I am able to solve all this? So it is years of practice and a lot of I've solved a lot of problems. So yes, I have developed it. I actually developed it when I was a student only. So back when I was a student, I was very good at problem solving. I used to practice a lot. I used to pay attention to my concepts in details. I would think about every concept. I would make sure that every concept should be super clear in my head. Everything, every small little thing that I'm reading, studying should make perfect sense to me. Okay, once I would do that, I would start practicing. Once I had practiced enough, So I would start with solving HCV. So a lot of students keep asking me that. So how did you prepare? That is what I did for my physics. Okay. That is what I did for my physics. I would just pay very close attention to all my concepts, practice. I would start solving HCV first. When I would complete HCV, then I would move to Erudov. And once I solved Erudov also, then I knew now I can solve any problem. That is it. All right, let's move on to the next problem of the day then. Okay, so today I have planned this session for 2 hours because I wanted to discuss at least 4 or 5 problems. Because how many problems have we discussed so far? 3 problems. Great. So we had a slow start, but we're catching up. All right, so let me bring you the next challenging problem for you to think about. So this question says one end of an elastic cord. So again, keep noticing the keywords in the question. So one end of an elastic cord is attached to a block of mass m, and the other end is held, keeping the cord relaxed. So initially, you are keeping the cord relaxed and vertical. Now the relaxed length of the cord is L. So relaxed length of cord is L, and there is a mark P at a height 0.8 L from the lower end. So there you see a small little mark P, which is at the height of 0.8 L from the lower end of this elastic cord. Okay. Now, if the upper end is slowly raised, the block leaves the ground. When the mark P reaches a point where the upper end is of the relaxed cord initially was. Okay. So what it is trying to tell you is that now you start raising this slowly, and when this point P essentially reaches here, that is when the block starts to rise. Okay, I hope you followed that. So the block leaves the ground. Oh, the block leaves the ground when the mark P reaches the point where the upper end of the relaxed cord initially was. The expression for the work done by the force applied by the hand is you have to find the work done applied by this guy, whoever has been applying this force, work done by this force. What will that be? So here are your options: MGL by 16, MGL by 8, MGL by 5, or MGL by 4. Okay. What do you think? Let's solve this quickly. Again, I would like you guys to write trying in the chat to let me know that you're trying, and I should be waiting for you. Trust me, this session is not much fun for me if none of you are participating. So make sure you keep participating. That keeps it interesting for me also, because see, otherwise just discussing the problems has no fun because I know how to solve them. If I see some attempt from you guys, that is where I can also help you. Whenever I see you are making some mistakes, if you're having some doubts, I can explain it right at that time. So that is why I would advise those of you who like watching the recorded session also, for this particular kind of session, it is always better if you attend it live. Okay. Because later also you might not follow everything in the solution. Though I try to give detailed solutions, but still you might not follow every bit of the solution, and it is better if you're live here to ask about any part that you do not follow. Okay. So please try this and see if you can solve this. So who all are trying? Come on, quickly let me know. Okay, this is again an easy problem, by the way. It's not too tough. Okay, not too tough, trust me. All you need to do is remember your basics and use a little bit of brain. That is all is required to solve these problems. Get your fundamentals strong, get your fundamentals right, and start using some brain. And trust me, you'll be fine with any problem. That's the beauty of physics. I think if you understand the concepts well, problem solving is very easy. Okay. All right. So game. I wish there was more participation from you guys. Come on. All right. Why don't I go ahead and solve this? And I don't know. Maybe we can end this series because none of you show active participation, or in fact, many of you don't even attend this live, which is weird. So, in case the timing is an issue, if you want this session to be held at a different time when you can attend it live, so you can let me know. Otherwise, I don't know if not many people are attending it also, and those who are attending it are not participating well enough. So, yeah, that trust me, that discourages us teachers. No. Okay, so let's think about this. Let's think about this. Let's assume that this is an elastic cord. So, elastic cords are just like springs. Let's say it has a force constant K. Okay, so let the force constant let the force constant of the cord be some K. Okay, so I am assuming that. Okay, so see, no, I don't think so. The right answer. If I remember it correctly, it was either A or B. Let's see. So if the force constant of the chord is some K, and now I will realize how much is this point shifting? This point is shifting by 0.2L. Okay, so I can say since P shifts by 0.2L. Now, can I say that consider this string, if the elongation, total elongation would have been x, imagine that this was stretched by some x, then what you would have noticed is if this end moves by x, so this is the 4/5 of the length, right? 4/5 of the length would have moved by 5x. I hope you can see that if the end of the string is moving by x, then the 4/5 portion. Okay, why 4/5? It is 0.8L. 0.8L means 8 by 10, that is 4 by 5. 4/5 of the portion would have moved by 4 by 5x. Half, by what amount would the midpoint move? It would have moved by x by 2, right? So can I say if here the total extension in the string is, so if the elongation in string is x, then that just means that 4x over 5 is 0.2L, which tells me about x, which tells me that x is 0.25L, correct? Now, once I know that the string is elongated by this, So can I say that the force that it is applying on the mass m is kx? At this point, you have been told that the mass block just leaves the ground. So if this has a mass m, so can I say, therefore, k times x must be equal to mg, right? And I also know, so when this guy has moved here, the work done by this external force should be equal to the change in all the energies stored, right? So you realize the block has just left the ground. So block has zero kinetic energy. It has zero potential energy. It did not gain any energy. So where did all the work go? All the work goes into the elastic potential energy or the spring kind of potential energy of the cord. Okay. So can I say the work done? Okay. So let's maybe add another page here. Just add another page here. So let's just say work done by the external agent is stored in the elastic potential energy of these cord. And I already know the formula for this, right? If the force is k times x, what is the energy stored? It is half kx square. Then I say work done would be equal to half kx square. Now I already know what kx is, so I can also rewrite this as half kx times x, right? This kx is nothing but mg, and this x I have already figured out how much that is. X was 1 by 4L. Let's just write those. What do I get is work done by the external agent is 1 by 2 times mg times L by 4, 1 by 8 GL. That is the answer. That is the correct answer to this problem. Okay. It's okay. No need to be sorry. At least you tried. That's all right. See, trying is better than not trying. Trying and giving the wrong answer is much better than not trying and just watching the solution to see what the correct answer would have been. So when you try, you are invested in the problem. Okay, you feel involved in the problem. So you will follow the solution also better and you will remember the solution better. You will probably not repeat the mistake that you did in the first time. If you haven't tried the problem yourself, then what happens is that you look at the solution, but trust me, chances are that you may even understand the solution, but you probably won't remember it for too long because you just saw the solution. You were not really involved in the problem. So trying gets you involved in the problem. So that is why I keep telling you, try. Doesn't matter even if you get it wrong. Okay. So I hope you guys followed how we solved this. If you have any doubt regarding the solution of this problem, then let me know. I will go over that part one more time. If everything in this problem is clear to you, then we can move on to the next problem. So I'll give you probably maybe 1 minute to go over the solution. Think about the solution, go over all the steps that we discussed, and let me know if you followed it. If you followed it good enough, we will move towards the next problem. Okay. Otherwise, I will go over and explain the part that you did not follow. Okay. This is your first page. Let's move on to the next page. Let me know if you followed all these steps. Okay. So I think 1 minute is up. So if you do not have any confusion about any of the steps of the solution, then I will move forward. And see, that is what happens Those of you who are attending, who are watching this recorded session, if there is one step that you did not follow or any step that you wanted more explanation with, you're not here to tell me. If you were here, you could have told me that, sir, this step I didn't follow completely. Can you explain this one more time? I would have done that. For that, you have to make the effort and come and attend the session live. Okay. All right. So moving on to the next problem. Okay, this is a very, very challenging problem. Very, very nice problem, in fact. So let's see you guys give this one a try. So here you've been told that, okay, so let's try and budget as much as we can. All right, here you've been told that two identical sleeves, A and B, each of mass M, can slide without friction on a horizontal rod. Okay, so let's start marking the keywords. First, two identical sleeves, A and B, each of mass M, can slide without friction on a horizontal fixed horizontal rod. Okay. Now, a load C of mass 2m is suspended from the midpoint of a light string. So, load C of mass 2m is suspended from midpoint of a light string in extensible cord of a length root 3 meters connecting sleeves AB. So, okay, so this is the cord which is connecting AB, and C has been connected at the midpoint of this cord. Okay. Now let's see what else the question tells us. Initially, the sleeves are at a separation L. So L was the length of the cord. Cord had a length L. Initially, you have been told that the sleeves, uh, initially you have been told that the sleeves are at a separation L, and are held. Load is motionless and held motionless. What is happening is, what is the initial condition? Let's try and imagine the initial condition. The initial condition should have been like this. So here you had this, you had this. So if they were kept at a separation L, then this cord would have been horizontal. I hope you guys can see that. This is where your A would have been. This is where your B would have been. This rod would have been just horizontal because this has a total length L, and you would have had C hanging here, and this was initially kept motionless like this. I hope you can follow this and understand this. This is what they are telling you about the initial situation. Okay, initially the sleeves are at a separation L and the load is held motionless. What can you conclude for the subsequent motion after the load is released? Now you are letting go of the mass C at this point to let the mass C go. Okay. Now, and if the acceleration due to gravity is 10, then you have these options. So option A says the maximum speed of the sleeves is root 10. The maximum speed acquired by the load is 2 root 5. The load descends a height of 1.5 meters to acquire this maximum speed, and before the sleeves collide, the net force on the system consisting of the sleeves and the cord and the load becomes zero once. So this is a very, very interesting problem. Try and solve this. Think about it. Very, very interesting situation. How you will analyze it. Just give it a little thought. Okay. So I will give you probably at least uh, I personally want to give you 5 minutes at least to think about this, but I don't know. Let's see. Since there aren't too many people online, I don't know how much use that will be. So hi for education. How are you? Good to see you after a long time. I don't know, where have you been? Okay. So is anyone trying this at all? If you're trying this, you can let me know. If you aren't even interested in trying, then trust me, I don't find much interest in hosting this session. See, if you are not actively participating live in this and you're trying these problems, so these are wonderful problems. This is a very interesting discussion. With the again, as I said, I like to have a discussion with students. So if this is just me solving problems, I can do that without coming online, right? So I would appreciate if you can take the effort of coming online and have a live discussion with me. Otherwise, if just solving the problems is concerned, I might as well solve the problems at my home in my quilt in this cold. Why would I be sitting out like this and solving this online? All right. Anyhow. So I'm still taking the time for those of you who might be watching this offline. Okay, let's see you guys try this. See if you can figure out how you could have solved this. Give it a try, guys. Okay. So again, the idea is to challenge yourself. So that is why I'm bringing you these stuff from first. Some of you requested it, and I thought if okay people are interested, then why not? Okay, all right. Yeah, I don't know. I don't know why you guys prefer watching recorded sessions more than watching live sessions. Trust me, you will learn way more in a live session than you will by watching recorded sessions. Okay, you will learn way more if you attend these sessions live. Because in recorded sessions, it's only a one-way conversation. I don't know. I could, I never could enjoy a one-way conversation. I would always want to discuss to understand my concepts well enough. Okay. Anyhow. So yes, everybody has their own way of studying, I guess. All right. So how about this question? I think I've waited long enough. Maybe I'll give you guys one more minute for those of you watching it or record it, or those of you who are live right now. I'm giving you one more minute if you can give me a response. If somebody could figure out how you will even approach this problem, this is a very tricky situation. Very tough to even understand how you will approach it. Okay. Hmm. I come online every time. No, I only come online once a day, and then on Saturday, especially for you guys. Oh, so that day, I think there was only one recorded session when I think yeah, I was taking it off for Diwali. So yes, I'm sure. So you guys would know how I would feel when you guys are watching it recorded and I'm not getting any response from you guys. How would you feel if all my sessions were recorded? So if I'm not getting enough interaction with you in any case, then yeah, I think Meet has a wonderful idea. I should just record me solving these and not bother about waiting for you guys to solve it and come live, right? You realize that. So Meet, but you realize this is as good as having a recorded session because I hardly am getting any interaction from you guys. I would have rather recorded this and when recorded this during the day sometime when I was free and been out right now maybe. Okay. All right. Anyhow, let's get started with how we would have solved this. So can I say due to the symmetry, can I say that if at any time instant these two are moving with this is moving with speed v1, this will also be moving with speed v1. Okay. I hope you can see that. Because of the symmetry, these two masses were identical. So two identical sleeves, okay, and the sleeves can slide frictionlessly, and the cord is at midpoint because of the symmetry. Whenever C will fall, okay, so when C starts to fall, you will realize these two will start moving in this direction. I hope you can see that. So imagine when C is going down, these two will start moving like this, and because of the symmetry, these two will always move with the same speed. Correct? So let's say at an instant shown, the speeds with which these two A and B are moving is V1, and at this instant, the C is going down with a speed V2. Okay. And I will also assume that at this instant, this height, or I can say that C has come down by a distance y, and let's say that these two are both x away. I'm assuming these values. So let the speeds of A, B, and C be as shown at some instant, as shown at the instant when C has descended by a distance y. Okay, okay, so you should start managing that better, okay, for education. Okay, when C has descended by some distance y. So you realize I can relate the velocities of V1 and V2. How? Let's see. Can I say in this triangle, let's call this point some D. Now, do you realize in the triangle ABC, what can I see? In triangle ABC, can I say that this length would be L by 2? If the total length of the chord was L, then you realize half the length would be on one side, half the length would be the other side. Okay, Meet. Can you make sure that you're telling your friends also and more people are coming online and interacting live? No? Okay. So, all right. And this will also be L by 2. So in this triangle, can I say that y square plus, all I'm doing is going to apply Pythagoras theorem, plus x by 2 whole square, this would be equal to L by 2 whole square. Okay, I hope you can realize that this is Pythagoras theorem, nothing else. Now what I need to do is let's differentiate this. If I differentiate this, then what am I getting? I'm getting 2y dy over dt plus I am getting 1 by 4 into 2x into dx over dt was 0. Correct? I hope you guys are following this. Let's cancel out those. And what is dy by dt? Dy by dt is v2. I hope you realize this is nothing but v2. So I'm getting y v2 should be equal to minus 1 by 4 x dx by dt is minus v1. Why minus v1? Because this is decreasing dx. Minus v1. That is how I can relate these two. Okay, so let's try and relate these two with y. Okay, so yeah, sure. Let me just solve this problem. Then you can ask me that. So what I'm getting is that v1 is 4 y over x times v2. Now you'll also realize what is y over x. Y over x, if this angle was theta, y over x is tan theta. Agreed? I hope you can see that this is nothing but tan theta. Or I can say, now we can also do one thing. We can write everything in terms of y, because I want only a single variable. Okay, so I can, let's see. Okay, okay, me. Thank you so much. So can I say that v1 v1 equals v2 tan theta. Okay, so that is the relation that I get between v1 and v2. Now let's talk about some energy consideration. So as the c is coming down, v1 and v2 are the speeds that these masses are gaining, right? So where are these speeds coming from? I hope you realize that this is coming from the kind of potential energy that c is losing. Okay. So can I say, let's say the k gained by a, b, and c equals pe lost by c. I hope you can see that. There is no external other force that is doing work. All the slides are frictionless. The chords are ideal, so there is no other thing doing work. So whatever kinetic energy these two masses A, B, C are gaining, it is coming at the cost of the potential energy C. So in this particular equation, since it started from here, okay, where the speeds were zero. So what is, when it has come down by a distance y, the loss of the uh, the loss of kind of potential energy by C would have been equal to mg times y, and this will be 2 mg times y because the mass of C is, okay, Abdullah Malik. I don't know who you are remembering here. So I think you are at the wrong place. This is a session for Olympiad level problems. Yes. So C has a mass of m, and A and B both have C has mass of 2m, and A and B both have masses m. So what I can say is loss of potential energy by C is 2 times mgy. This would be equal to half m v1 square. I think I've taken the velocities as v1, yes, into 2. This is the kinetic energy of A and B plus half to 2m to v2 square. Yeah, I hope that is clear. So now what I will get is this, and this gets cancelled, this and gets cancelled. All the m's get cancelled. So what I can write is 2g of y would be equal to v1 square plus square. And if I substitute this value of v1 here, so I will get v2 square 1 plus tan square theta. 1 plus tan square theta will become sec square theta. So 2gy equals v2 square sec square theta. Okay, so now, now what I need to do is I will realize that still everything, still I have two variables. If I want to find v2 as a function of y, I still need either y in terms of theta or theta in terms of y. So which one would you like to change? So I can write the entire equation in terms of theta also and in terms of y also. So let's try and write everything in terms of theta. If you want to write everything in terms of theta, from here what you will see is that what is sine of theta? Okay, so in triangle, you can say in triangle ABC, sine theta is nothing but y over L by 2. Correct? So that will tell me that y equals L by 2 sine theta. So let's substitute that value here. So I'm getting 2g L by 2 sine theta cos square theta equals, gets cancelled. So this is the expression, this is the final expression that I have. Okay. Now, how does sine theta times cos square theta be? Is that an increasing function or a decreasing function, or how does it vary? So let's try and think about sine theta first of all. Sine theta is an increasing function. Okay. About cos theta. Cos theta is a decreasing function. Cos square would be a decreasing function. How about the product? We'll need to check. So let's imagine one thing at 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 theta equals 0. You will realize v2 is 0. How about theta equals 90? What will be the value? At theta equals 90, you will realize because the cost would be 0, v2 will again be 0. So this function increases and then decreases to 0. Okay, you can draw the graph also. So now what I know is that it will get a maxima somewhere. And if I can find the maximum speed acquired by load, then what you will do is, if you can find the maximum speed acquired, that is what has been asked in the question. Okay, so it has a maxima at some place. So for maxima of v2 square, I need to find the maxima of this function. Let's call this something. Let's call this some alpha. Okay, if I can find the maximum value of alpha, then that will, okay, Barack Obama. Okay, so again, if you need to talk about irrelevant stuff, Mr. Obama, you can go. If you are here, if you're interested in finding the solutions of some interesting physics problems, then you can stay. Okay. All right. So if I find alpha max, then I will get a v2 max. Okay. So let's see. Since alpha is equal to sine theta cos square theta, for finding the maxima, I will find a d alpha by d theta, which would be cos cube theta, and I will have minus sine theta into 2 cos theta into minus sine into another sine theta, and this would be 0. Let's see what I'm getting here. I am getting that cos cube theta minus sine square theta times cos theta equals to 0. I can remove this one cos theta, okay, and again I'm getting tan theta equals 1 by root 2. That this is the maxima point. This is the point where v2 will become maximum. Okay, I hope you can figure that out. This is condition for v2 equals. So let's see if we had something like that in our options. So it says the load descends by a height 1.5 to acquire maximum speed. So let's see. So once I know this, I can easily calculate. Let's make ourselves a triangle and find these values. Okay. So let's imagine you had this triangle, right? Where this was theta. And tan theta is 1 by root 2. So perpendicular would be 1, this would be root 2, and this would be root 3. Correct? Okay. So let's see. I already got that y. So this is the triangle that you would have had. Okay. So what you will realize is, what is sine theta? So it's sine theta. Sine theta from this triangle would be perpendicular upon hypotenuse 1 over root 3, and cos theta would have been root of 2 over 3. Right. Now all I need to do is remember that v2 max would be when the tan theta is 1 by root 2. So all I need to do is substitute these values of cos theta and sine theta here, and I'll get v2 max. So v2 max square equal to g times l times, I had a sine theta and cos square theta. So sine theta is 1 by root 3, into cos square theta, which is 2 by 3. Okay. And what is the value of L? Let's substitute the value of L. L was 3 root 3. So if I substitute this value of L, 3 root 3 here, see what I'm getting? So G also was told to us as 10, I think. G was also 10. Let's start substituting all the values. So I'll have 10 into 3 root 3 into 2 over 3 root 3. So that is getting cancelled. V2 max square, I'm getting as 20. So V2 max is 20. Okay. So let's see if we had that as any option. So yes, we did. This is root 20. So this is correct. Maximum speed acquired by the load C is 2 root 5 indeed. Okay. Now the load descends by a height of 1.5. Let's see. I hope you remember what was y. I think we substituted y somewhere in terms of theta, right? Where did we make that substitution? Okay, so here y was L by 2 sine theta. Okay, since y equals L by 2 sine theta, so I can calculate the y at which this has achieved the maximum velocity. So L is 3 root 3 over 2 into sine theta is 1 by root 3. So turns out, yes, the y is in fact 1.5 meters when maximum velocity is achieved. So option number C is also correct. Okay. Now, option D says before the sleeves collide, the net force on the system of the sleeves and the cord and the load becomes zero once. So can that happen? You think happening? So you realize the speed is increasing first, and then the speed is decreasing. So can I say that at some point the acceleration of the point C is going from positive to negative? At some point it must be zero. So when the acceleration of C is zero, can I say that the net acceleration of the CM in y direction is also zero? In the x direction there can be no force. In the y direction also the net force has to be zero when the center of mass has a zero y acceleration. Okay, I hope you can figure out that, and that is why D is also correct. Okay, think about it. See, A and B are always moving in x. Okay, so the CM acceleration of CM is only due to the acceleration of C. And as I said that since C's y acceleration goes from negative or from positive to negative. So at one point it must be zero. At some point it must be zero. So whenever the acceleration y acceleration of C is zero, at this instant, see the acceleration y acceleration of A and B is always zero. If at some instant the y acceleration of C is also zero, then at that instant, can I say ACM y is also zero? Now, if the ACM or the acceleration of center of mass in y direction is also zero, so I can easily conclude that the net force in the y direction is also zero. Now, since there is no force in any case in the x direction, okay, there is no force, external force. If I am taking the system as sleeves, the cord and the load. Okay, so if I take all of them into one system, there is nobody applying any external force in the x direction in any case. So in x direction, I know ACM is always AX is always zero. If AY is also zero, then the net acceleration of center of mass is zero. Therefore, I can conclude that the net force on my system has to be zero. That leaves me with only option number 1 now. Let's see if that is correct. What is the maximum speed of the sleeves? So once I found the expression for V2, you will realize V1 was V2 tan theta. So I can find the expression V1 also, which is the speed of the sleeves. So let's just add one more page and get this question out of the way. Okay. So we know that V2 was, how much was V2? Just let's remember. GL sine theta cos square theta, and V1 was V2 tan theta. Correct? Yeah. Yeah. V1 was V2 tan theta. So now what I can say is, therefore, V1 would be equal to, if I multiply this, so I have GL times sine square theta cos theta. Correct? So to find the maximum of this, I need to find the maximum of this. So let's call this some beta, and I think if beta is equal to sine square theta cos theta, to find the maxima, I will put d beta by d theta as 0. So that will give me 2 times sine theta times cos square theta, and I will have minus sine cube theta equals 0. So for maximum of this, I am getting another condition. So that is that tan theta equals root 2. That is where this will become maximum. Okay, if your tan theta is root 2. Okay. So when tan theta is root 2, then also I can root 2 1 sine theta, you will realize will be sine theta. Sine theta would have been root 2 over 3, and cos theta would have been root 1 over root 3. So you can substitute these values and find the maximum value of V1. Okay, therefore, V1 max, that would have been GL. So G was 10, L was 3 root 3 into sine square. Sine square is 2 by 3 into cos, which is 1 by root 3. Okay. What you realize is that this and this goes with this, and V1 max is in fact 20. The maximum speed of the sleeves is 20 meter per second. Okay. So option A was incorrect. This is the only incorrect option. All the other options are correct. Yes, Meet. Now I can take up your question. So you say the two particles move on a circular path, just one inside and the one just outside, with angular velocities of omega and 5 omega starting from the same point. Then this is true of course. They cross at intervals of time pi 3 omega if their angular velocities are directed opposite to each other. Pi over 3 omega, is it, or pi over omega? So that is wrong, by the way. That is wrong. Since they are moving in the opposite directions, right? Angular velocities are directed opposite. So their relative omega would be 6 omega. Relative omega would be 6 omega. Oh, okay. So they will cross each other when their relative displacement is 2 pi. So yes, 2 pi over 6 omega. So the answer is pi by 3 omega. That is true. Okay, Meet. So as I said, when they are moving in the opposite directions, just add the omegas to find the relative omega. And in that relative omega frame, one is stationary, other is moving. Okay. Yeah. Pi by 3 omega is correct. So since your relative omega is 6 omega and relative angular displacement would be 2 pi, so you will have that answer. Okay. Okay. That the answer is true. All right. So we have run out of time. So I had two more problems, two or one, I don't know. Yeah, two more problems I had thought I will discuss. So 2 subjective problems I had planned to discuss, but since we are out of time, so why don't you do one thing? You can try this later. So this is your homework problem. You take a screenshot of this or watch this later. Try and solve this one. And then if you are able to solve that or not, you can try this other one also. So initially I had planned to discuss these 2 subjective problems also, but since we don't have enough time to solve them right now, so I will leave them to you. You do some hard work, try and solve these. If you cannot solve these, then you can leave that thing in the comment section. If I get a comment saying, ki, sir, I could not solve, let's call this problem number 1, work problem 1 and homework problem 2. So whichever problem you can't solve, and if you want me to solve in the next session, you can leave that in the comment section. So if I don't have any comment, I will not discuss these problems in the next session. Next session, I will probably take up momentum problems. Okay, or yeah, work energy is done. So momentum problems. If you think that you want a solution to be discussed, then leave that in the comment section. Okay, so yes, Meet was saying. So this is very, very simple. Okay, so all right. Let me try. Show you what I'm trying to. So here is the circle. Okay. So all you need to do is that one particle is here, another particle is here. Okay, so one is moving in this direction with omega, and the other is moving in the opposite direction, right? In the opposite direction with 5 omega. So in the reference frame of one, if you go, then it will appear stationary, and the other one will move with 6 omega, right? So in the reference frame of one, let's go in the reference frame of the blue one. Okay. So what you will see there. So in the reference frame of one becomes stationary. The blue one becomes stationary. Stops. And how about the green one? The green one would appear to move with an angular velocity of 6 omega. Right? And when they will meet after this guy has completed this one circle and rotated by an angle of 2 pi. Okay. So how much time will it take in rotating an angle of 2 pi if it is rotating with 6 omega? Time would be 2 pi over 6 omega. That's it. Which is omega by or pi by 3 omega. Okay, I hope you got that. So you go to the reference frame of one becomes stationary. So the other, when it has to meet, it has to come back to this point. It has to travel an angle of 2 pi. Okay. So I hope that was clear. This is simple enough. You shouldn't have any doubt here. Okay, so that is it. That is where I would like to wrap up today's session. And before I leave you, let me remind you that you can get yourselves the plus subscriptions of Unacademy by following these steps. All you need to do is go to the plus section of your app, select your goal as IIT JEE, and click on the get subscription button. Then when you're directed at the payment page, choose a plan which suits you. Use the code RDLIF to get 10% off and click on proceed to pay. All right. So when you enroll here, you can when you get yourselves this subscription, you can enroll in these courses that are being hosted by the JEE English team on Unacademy Plus, and these 4 more courses that are being hosted on the Plus section by the Unacademy team. Again, if you like today's video, then don't forget to press the like button, share it with other friends, and from next session try and attend this session live. Okay. Don't forget to press the bell icon to keep receiving all the notifications of all the lectures and schedules happening on the JEE English channel. And the PDF, I don't know, do you really want the PDF of all the solutions? I think since there is not much theory, if you want the solution, you can always watch the solution. Okay, so yeah, this is probably not needed. All right. Now, before I leave, let me also remind you about the Unacademy Combat. Next event is happening live on 22nd of November. You can enroll now using the code RDLive and win yourself some really cool prizes if you do well, of course. Those of you following us on the JEE English channel of YouTube should be connecting with us on the Telegram app. Okay, somebody is asking, is the Unacademy subscription free? So no. These are the fees that you have to pay. For 6 months subscription, you have to pay 28,000. 12 months subscription, you have to pay 38.5 thousand. And for 24 months subscription, you have to pay 56,000. Okay, so yes, whoever asked me that, I hope you are clear now. All right, so again, to discuss this, finally, one last time, if you plan to get your subscription, if you like my lectures, if you like to enroll in my courses, you can use this code to get yourself the Unacademy subscription and enjoy a 10% off, all right, on your next subscription. So that is it from my side. I will see you guys next time, next Saturday at the same time, 8:30, and we will take up the topic momentum, I think. And you try those last two problems, and if you want any of those problems to be discussed in the class, then you can leave, you can say so in the comment section, and I will discuss that. Okay. So till next time, you guys keep studying hard, keep practicing.